Greetings everyone. In this tutorial, I'm going to cover question 5 based on trigonometry. This is from the June 2022 paper. The question reads as follows. In the diagram below, P with the given coordinates -4 is a point in the Cartesian plane. R is a point on the positive x-axis such that obtuse angle POR is theta. The information is given in the Cartesian plane here. Calculate without using a calculator the length of OP. So we are calculating OP. So what you do here is to drop a line from O to the x-axis so that you can form a right angle triangle. So you got a right angle triangle OP and some point here where it touches the x-axis, and then the coordinates, this is the x value and the y value. So this will give you the length from O to that point. We can call it x. That will be a -7, and the y value is a 4. So basically we have got a right angle triangle with sides -7 and 4. Now OP will be our hypotenuse, which is what we are calculating. We can call that R. So from Pythagoras, we can use Pythagoras theorem, which is simply written as x squared plus y squared is equal to r squared. The r is the hypotenuse OP, and the x is the x coordinate, and the y is the y coordinate. So we can say therefore OP squared is equal to x squared, that is a -4. Okay, that is a y. Then -4, that is a +4 squared plus a -7 squared, which gives 16 plus 49, and that will give us a 65. Therefore, our OP is √65. Remember, don't express this one to decimal because we are required not to use the calculator here. So don't enter this in a calculator to get a decimal value. Just leave it in said form. 5.12, calculate the value of tan theta. So what we have here, we now know the value of the hypotenuse OP, which is a √65. So we can write our value here, that is √65. So now we know from the definition of a tan 5.12a, tan theta is defined as y over x, the y value over the x value. So in this case, the y value is a 4 over the x value is a -7. So we can write this as -4/7. That is the value of tan theta. Calculate the value of cos theta minus 180. Here we have to use, you realize that this is a reduction formula. We have to use the reduction formula. So first of all, let us reduce the cos theta minus 180. So this is cos theta minus 180. When we reduce this, remember with the function values of theta minus 180 or 360 plus or minus 180, when we reduce it, the name of the function does not change. So cos will remain a cos. So we are going to have a cos, and the theta minus 180 is replaced by theta. Now we have to determine what quadrant is this theta minus 180, and that one is a third quadrant. So theta minus 180 is a third quadrant. So in that case, we use a cast diagram. Cos is negative in the third quadrant. So when we reduce this, it will give us a function value of theta, which is a cos theta. Now, according to this diagram here, we are going to have our cos theta is adjacent over hypotenuse, which is a -7. So -7 over root of 65. So our answer therefore will be cos theta minus 180 will be equal to positive 7 over root of 65. Okay, we'll leave it like that. Then question 5.2, determine the general solution of sine x cos x plus sine x is equal to 3 cos squared x plus 3 cos x. Let us write it here. 5.2, sine x cos x plus sine x is equal to 3 cos squared x plus 3 cos x. Now, first of all, you'll find that there's a repeated term here, which is sine x, and here there's a repeated term, which is a cos x, so we can choose to factor out sine x. So we have here sine x out, we'll get a cos x plus a 1. This will be equal to, here we can also factor out a 3 cos x. So 3 cos x, we are going to get a cos x plus a 1. Now we can divide by a cos x here. We can divide by a cos x and divide by a cos x and divide by a cos x plus 1. This is a cos x plus 1 and a cos x plus 1. Okay, let's just do it in steps. So first of all, let's bring this cos x to that side. So I'm going to have, there's a next step, sine x into cos x plus a 1 will be equal to, now this cos x is divided, so I'm going to have a 3 by cos x plus a 1. Now I have divided by a cos x over here. So now, and then I'm going to divide this side also by a cos x plus 1, and here by a cos x plus 1. So this will divide out, this one will divide out, cancel out. So we are now going to have a sine x over cos x is equal to, that will give us a 3. This is 3 by 1. Now from identities, sine x over x, this is a tan x. So this is a tan x is equal to 3. And remember, we are looking for the general solution. We're looking for the general solution. So when we are given tan x is equal to 3, the first thing is to get the reference angle. So our reference angle here is arctan 3. Okay, so punching that one in our calculator, shift tan 3, we are going to get a 71.565 or 57. So our reference angle is 71.57 degrees. Now to get the general solution, remember the general solution for a tan equation is our x is equal to reference angle plus 180 multiplied by k, where k is an integer. So now our reference angle is 71, So therefore we can say, therefore our x is equal to 71,57 plus 180 times k, where k is an integer. So that gives us the final answer to that question. Question 5.2. Then 5.3, given the identity sine 3x over 1 minus cos 3x is equal to 1 plus cos 3x over sine 3x. So prove the identity given above. 5.31. So let's just put it here. 5.3.1. Now the bottom line here is to take one side, as we do with every identity. We are just taking one side and proving that it is equal to the other side. So I can take the left hand side, which is this one, sine 3x over 1 minus cos 3x. Now I'm going to work on this one, manipulate this one until it gives me a 1 plus cos 3x. Now one thing that we can do here, especially when you are given a denominator which is made up of two terms, is to multiply that denominator by its conjugate term. Now what I mean by that is you take the sine 3x, leave the sine 3x over, now here I've got a 1 minus cos 3x. So we need to multiply that by a 1 plus cos 3x. Cos 3x. Or at the bottom and also on top, multiply that by 1 plus cos 3x. Now the conjugate term, what I mean is, here you see it's a 1 plus cos 3x, here it's a 1 minus cos x. More like what we find in a difference of two squares. But this is not a square number. So if one term is positive here, the other term is a negative. So multiply this. We haven't changed anything because this is a 1 plus cos 3x over 1 plus, so we are simply multiplying it by 1, but we are just manipulating it in that way. So now what we have to do is to multiply the top part and also the bottom part. So the top part is a sine 3x into 1 plus cos 3x. Let's leave it like that. And at the bottom, it's a 1 plus 1 minus cos 3x, 1 plus cos 3x. So this is going to give us a 1 minus cos squared 3x. So after this step, we are going to take the numerator, which is the sine 3x, which is the sine 3x, leave it like that one, 1 plus cos 3x, over the denominator is a 1 minus cos squared 3x. Now this reminds us of a square identity. The square identity is the one that is stated as follows: cos squared x plus sine squared x is equal to 1. Now when I take this cos squared x to that side, I'm now going to have a sine squared x is equal to 1 minus cos squared x. So now here we have got a 1 minus cos squared 3x, so which is equivalent to a sine squared 3x is equal to 1 minus cos squared 3x. So we can write this as a sine squared 3x, okay, from the square identities. Now simplifying that further, we have a sine 3x here. Remember, sine squared 3x, it means sine 3x by sine 3x. So when we cancel this, we will see there's one sine 3x left here. So eventually we are going to have a 1 plus cos 3x divided by a sine 3x. So this is our left hand that we have simplified and manipulated to that stage, which is then equal to our right hand side, which is 1 plus cos 3x. So we can say therefore this is equal to the right hand side, which proves our identity. Therefore the left hand side is equal to the right hand side. Question 532, determine the values of x in the interval x is equal to x element of numbers from 0 degrees to 60 degrees, for which the identity will be undefined. Now you always find this question is very common in the exam questions. So for an identity to be undefined, in this particular case, our denominator should be a 0. This should be equal to 0. Undefined, it means you have got a number divided by 0. So you can equate sine 3x 0 or 1 minus cos 3x is equal to 0. So we can take sine 3x being equal to 0. That one is the easy way. So whenever you see this question, determine the value of x for which the identity is undefined. Undefined, it means your denominator should be a 0. Your denominator is a 0. So here our denominator is a sine 3x. Now when it is a 0, whatever number we get on top divided by 0, it will be undefined. So here we can say therefore 5.3.2 for identity to be undefined, sine 3x is equal to 0. So here again we are back to trigonometric equations. We have to apply our reference angle. Again, what is our reference angle? Reference angle is equal to arc sine 0. So you can punch that one in your calculator, arc sine 0, but it will be 0. So arc sine 0, that is 0 degrees. So which means our reference angle is 0 degrees. So we're going to say which is equal to 0 degrees. Now for the sine ratio, for us to get the 3x, which is our angle now, so our 3x will be equal to a reference angle plus 360k. Okay, that is the first part. Or you can have also a reference angle, 3x is equal to your 180 minus reference angle plus 360k, where k is our integer. So these are the two parts that define the general solution of a sine function. So now here we got our reference angle is 0. So we are going to have 3x is equal to 0 plus 360, that is 360k, okay, or 3x is equal to 180 minus that is 180 plus 360k, where k is a whole number. Now our x therefore is going to, we divide by 2, that is 120k, or x is equal to, here divided by 3, that is 60 degrees plus 120k divided by 3 by 3 by 3. So these are the two. Now we have got a restricted domain here. They want the answers from 0 to 60 degrees. So now we have to test the values of k that give us those two values, that range. So we have to come here, x is equal to 120k, or x is equal to that. Now what I always encourage, you can make it a table. You can create like a small table. Let's say for this one, this is k, -1 and 0, 1 and 2, and here also you can have your k values. -1 you can start anywhere, but -1 makes sense because we don't want to go far. When it is -1, that will be -120, so that is far away from our domain. So let's start from the -1, 0, 1 and 2. You can, yeah, 2 fine, but that will be 5 as well. So just test the values and see what will be your x, what is your x for each value of k. Now when your k is -1, substitute here -1, our answer will be -120. That is out of the way. When k is 0, so our value will be a 0, which is acceptable. When k is 1, our angle will be 120. 2, that one is out. Okay, so then we also do it here when k is -1. When k is -1, this is going to be -120 plus 60. That is going to give us -60. When k is 0, that is going to give us 60 degrees. When k is 1, that is going to give us 180. So you find that the other angles, they are out of the range. The only angles that are within the range is the 0 and the 60. So we can say, therefore, to write the answer to that, therefore our x is equal to 0 degrees, or x is equal to 60 degrees, which are the angles that fall within the range, actually the domain that is given 0 degrees and 60 degrees. That concludes that question with the 18 marks.